All right, now I've gone to the top of the next page. So if you go to page 38 and take a look at the construct understanding, again, they give us four equations here, and they want us to match the graph with the equation. It looks a little tougher because these aren't just quadratic; these are higher order. We have this is a polynomial of the n equals 5, the fifth order, so that'd be quintic, right? This would be quartic. This one's cubic, and this one's quartic again. I think I'm going to organize my answers here. So here's a 1. I'm going to nice bright red. 2, 3, and 4. And let's talk about this in terms of what degree each of these equations are, and then we'll take a look also at the leading coefficient. So the degree and also the leading coefficient, whether it's positive or negative. Plus or negative question mark. So the first one here, the degree, the highest degree is this first term, and that is the fifth. It's a degree 5, and the leading coefficient is negative. So what does that tell me? So if it's of a degree 5, if I was just to make a quick sketch of what degree 5 looks like, it means that it's going to have kind of like 5 arms, or a maximum of 4 turning points, 4 local maximums or minimums. If the leading coefficient is negative, here that negative x to the fifth, that means as x gets really large, y is going to be going downwards. So it's got to start like this. And then if I think about sort of like the number of arms you can have, that'd be 1, 2, 3, 4, 5. So this is just one weird example where you would have a fifth degree. So you can count 1, 2, 3, 4 turning points. It goes down towards negative infinity as x gets positive, and it goes up to positive infinity for y as x gets negative. So this is a characteristic of an odd. Degree 5 is an odd degree, so you know it's like one goes up, one goes down, and if the leading coefficient is negative, that means that y is going to get increasingly negative as x gets larger. So is there any one that would fit with this category at all? Just realizing that these turning points are totally arbitrary. I'm looking, it looks kind of similar to this last one. So as a candidate, 1, 2, 3, 4, 5 kind of arms to it, or 1, 2, 3, 4 turning points, and it definitely fits this characteristic. The textbook isn't very good. They don't put the arrowheads at the very end, and we should be doing that. So this looks a lot to me like it could be number 1. So we'll put it in there as a candidate. Number 2, we're going to take a look here. So this is of degree 3. So if we recall, that's cubic. And the leading coefficient is positive. So if the leading coefficient is positive, that means as x gets increasingly large, y is going to get increasingly large. So it's going to start from that way. And then since it's cubic, it'll have a maximum of 2 turning points, or sort of 3 arms. So 1, 2, 3 arms. Okay, so maybe something like that. And who knows where the local maximums or minimums are. Is there a graph that looks like this? Yes, this one looks like that. So this is a good candidate for number 2. Number 3, let's take a look at it. Y equals 2x to the fourth, so it's of degree 4, and the leading coefficient is positive. So these were odd. So odd, 5 and 3 are both odd. Odd, you can see, one goes up, one goes down. One goes down, one goes up. When it's even, they're going to be the same. They're either both going to go up or they're both going to go down. If the leading coefficient is positive, so one example of this, of an even one, where it's positive, would be y equals x squared. And you remember how for this one they go up, don't they? It opens upwards. So this is another even one, except it's to the fourth. So it could look something like this. Okay, so the maximum number of turning points would be 1, 2, 3, and that looks mostly like number 3. Okay, I have to point out, I do say like the maximum number of turning points is 3. If you had y is equal to x to the 4th, in fact, it would end up looking a lot like y equals x to the square, just narrower. So it ends up looking like this. So in fact, it still has the opening up, the ending part is still the same, but the number of turning points could be less. So of degree 4, the maximum turning points would be 3, but it could just have one turning point. So you got to watch out for that. That's why I was saying that these are all candidates. Let's see if 4 works, and then if it does work, then we're good to go. So for equation number 4, it's of degree 4, so that's even, and the leading coefficient is negative. So it's going to be different than the last one in that the arms will be coming down on the end. So I'll just sketch out what it might look like that. And it does work with this third one here, so put it 4. Okay, give me a second, I'm just going to pause.